So this is our last slide on solving log equations, and a couple new techniques are going to sneak their way in. Number 6 asks us to solve the log of 100x plus 25 minus the log of 5x is equal to 2. My focus starts off on the left-hand side, and I'm going to use the properties of logs backwards to condense that to a single log. Because we have a difference of logs, I know that this can be expressed as the log of a quotient. Now that I've gone ahead and rewritten the left side as the log of a quotient, I'm going to do a swing. Now there's no base actually written down, but we know in this case there is an implied base of 10. So I'm going to go ahead and write that in. If I do a swing, I'm going to start at that little 10. I'm going to swing up to the right, and I'm going to land at this big algebraic fraction right here. So I'm going to get the following. So in setting this up, I now have a proportion. I've got 10 squared, or 100, is equal to 100x plus 25 over 5x. So my next step will be to cross multiply. 100 times 5x will be 500x. So 500x will equal 100x plus 25. Subtracting 100x from both sides, I'll get 400x equals 25. And then dividing both sides by 400, I'll end up getting x equals 25 over 400, or 3/50. And of course, the reduced answer is probably the preferred answer. Let's move to our last problem. Number 7 has us solve the log of x plus 2 plus the log of x is equal to the log of 48. Like question number 6, I'm going to start on the left-hand side, and I'm going to take the two expressions containing log, and I'm going to condense by using the properties of logs. Because we have a sum of logs, I know this can be rewritten as the log of a product, the log of x times x plus 2. Now, x times x plus 2 can be thought of as x squared plus 2x, so I'm going to go ahead and do that distribution. At this stage, I have a log on the left and I have a log on the right. At one stage of the game, we introduced log to both sides, and now in problem number 7, I'm going to do exactly the opposite. And because I have one log on each side, I'm now going to remove those logs from each side. So I'm going to be left with x squared plus 2x equals 48 after I remove the logs. We're left with a quadratic equation, and we know to solve that we should start by setting it equal to 0. Fortunately, this appears to be factorable, x plus 8 and x minus 6. Setting each factor equal to 0, I get x equals negative 8 and x equals 6. Now, there is that rule that I've written at the top every slide, and we haven't really addressed it yet, and that rule I'll put a little asterisk by. It says the argument must be positive. So if we take our two answers that we got and we check them into the original, do either of these as our inputs yield an argument that's negative? Well, if we plug in 6, we have an argument of 8 and an argument of 6, which seems to be fine. But if I plug in the negative 8, we're going to have a problem for that second term. So we're going to have to reject this answer as extraneous, and the only answer that we're going to keep is x equals positive 6. So in this final video, we learned how to solve log equations in a variety of ways. I really do find this topic very interesting because of all the different ways that you can approach the problem, and I hope you did too.